This aeroplane is travelling with uniform motion. This means two things. In the first place, it is travelling in a straight line. Its direction of motion does not change. In addition, its speed does not change either. This car also is travelling with uniform motion. It is moving in a straight line. Its speed is constant. If a car travelling at 60 miles per hour with a uniform motion continues to travel for several hours, we should expect it to cover 60 miles in every hour. When any object is moving with uniform motion, it travels equal distances in equal times. In this case, 60 miles in every hour. This we can prove. This car makes a chalk mark on the ground every time one of the rear wheels makes one complete turn. The distances between chalk marks are the distances travelled by the car for single turns of the wheel. These distances are equal. Now a light has been fastened to the wheel. The speed is constant. For each turn of the wheel, the car travels the same distance. Each turn takes the same time. The car does travel equal distances in equal times. This can also be checked by watching the white lines go by. They are equally spaced. A car travelling with uniform motion travels equal distances in equal times and always in the same straight line. This rocket is travelling with uniform motion. In space, it could travel on like this forever. To change its speed or its direction, something is needed. A force. To start this boy moving, the same thing is needed, a force. Once he is moving, he might be expected to keep on forever, like the rocket, but he will eventually slow down and stop. This must be brought about by the action of a force. This force is friction. This surface is covered with sandpaper. So is the lower surface of the wooden block. To start the block moving, a force is needed. It slows down quickly because of the force of friction. This force acts between two surfaces which are rough. As one surface moves past the other, the rough parts hit against each other. This polished metal weight looks very smooth. It should slide a long way, but it soon stops. Although these two surfaces look very smooth, under a microscope we see that they are really quite rough. There is still a force of friction which will bring the weight to rest. The force of friction can be reduced by lubrication. The surfaces are kept apart by a thin layer of oil. The weight moves much further, but there is still some friction. Here is a polished wood surface and a piece of smooth plastic. The force of friction brings the sliding plastic surface to rest. an inflated balloon is fastened to the piece of plastic. Air from the balloon is coming out of this hole beneath the plastic disc. The plastic disc is actually resting on a cushion of air. Friction is now so very small that the disc almost moves with a constant speed and in a straight line. This is the principle of a new form of transport, the hovercraft. A human cannonball does not move with uniform motion. He is slowed down by the force of friction, air friction. Nor does he travel in a straight line. He is pulled down by the force of gravity, the force which tries to pull everything down to the ground. If there were no friction to slow him down, and no force of gravity to pull him down, he would travel with uniform motion, with a constant speed and in a straight line. The energy of a rocket's engine is used to push the rocket up against the friction of the air and the downward pull of the Earth's gravity. When the rocket is in space, there is no friction. There is no air. It is not pulled by the force of gravity because it is too far from the Earth. The rocket travels with uniform motion. Everything will either remain at rest or move with uniform motion unless it is acted upon by forces. This is a law of motion first stated by Sir Isaac Newton. It is his first law of motion.